Welcome to Module 5 of the BIG-IP LTM Essentials web-based training course. In this module, we'll explore the Profiles feature of BIG-IP. Note that this course assumes an intermediate level of TCP/IP networking knowledge. See the Course Overview module for more details. This course contains audio narration. You may want to adjust the volume to the desired level on your speakers or earphones. If you need instructions on how to navigate within this training interface, refer back to the Course Overview module. Click the arrow at the bottom of the screen when you're ready to continue. This Profiles module does not contain a lab exercise. This is because the module covers only general concepts, which is not enough background for working with profiles in a lab setting. Instead, you'll work with profiles in the lab exercises for Module 6. If you recall from Modules 2, 3, and 4, Bob, the fictitious IT administrator for Termark Limited, whom we're following throughout this course, has now configured several virtual servers, pools, and monitors. He has spent some time examining the different applications that BIG-IP will be managing at Termark, and realizes that he has a problem. One of the applications requires that the user stay with the same server for their whole session. If BIG-IP load balances to a different server within one client session, it will break the application. A client session is defined as a series of TCP connections, or for HTTP, it could be a series of HTTP request-response pairs. Bob's wondering if he can force BIG-IP to send the returning client connections to the same server in certain situations. So, let's start learning about profiles. By the way, if you've not met Bob yet, you may want to return to the Course Overview module and review the details of Bob's scenario. Module 5 contains 2 lessons. In Lesson 1, we take a look at several profile concepts and why some profiles are dependent on other profiles. Lesson 2 demonstrates how to configure profiles. It also discusses the relationship between parent and child profiles. Note that profile configuration is discussed for specific applications in later modules, such as persistence and SSL termination. Let's get started. Lesson 1, Profile Concepts. After completing this lesson, you'll be able to explain how you can use profiles to alter the default behavior of traffic through a specific virtual server, explain the advantage in applying one profile to multiple virtual servers, and explain why some profiles are dependent on other profiles being configured. Profiles contain settings that instruct BIG-IP how to process traffic through that virtual server. Why would you want to change a virtual server's default traffic processing behavior? Bob has presented us a classic reason. From Modules 2 and 3, we know that the default behavior for a standard virtual server is to load balance traffic. Bob has an application that stores information about the client only on the server to which the client originally connected. If the client returns on a subsequent connection and BIG-IP load balances to a different server, the application breaks. To prevent this from happening, you can apply a persistence profile to the virtual server in question. A persistence profile tells BIG-IP how to identify a returning client and persist subsequent client connections to the same server rather than making a new load balancing decision. The persistence profile takes precedence over the virtual server's default load balancing behavior when working with returning clients. Another valuable reason for profiles is duplicating settings to multiple virtual servers. Bob also knows that his application needing persistence receives its client traffic from many different networks. Bob has decided to use multiple virtual servers to handle this traffic coming from different networks. All of these virtual servers point to the same pool and can use the same persistence profile. The following slides show several examples where profiles are used: persistence, SSL termination, and FTP protocol. A common misconception is that a persistence profile overrides the load balancing decision altogether. Let's clear up that misconception right now. Even if a persistence profile is configured, BIG-IP performs load balancing for a virtual server. A persistence record is created for a client or group of clients for a given time period or timeout. If there is a persistence record for that client, then BigIP will persist the client connection. Otherwise, it is load balanced. When the persistence record times out, or a new client initiates a connection, that client connection is load balanced. Subsequent connections from that client persist before reaching the timeout. So how does BigIP identify a returning client? One persistence method uses the client source address, another an HTTP cookie. Identifying the client is a somewhat difficult issue, though, and the reason that there are different types of persistence profiles. For more details on persistence, refer to Module 6. A second example where a profile is used to change a virtual server's traffic behavior is SSL termination. Let's say you have an HTTPS virtual server. You created one in the Module 2 lab. The client traffic to this server is encrypted from the client to the server. But what if BigIP needs to examine some of the encrypted content? And what if you want to offload the SSL encryption and decryption work from your servers? These are two excellent reasons for using a client SSL profile and having BigIP terminate the SSL session rather than the servers. Because it contains SSL accelerator hardware, BigIP can speed up SSL processing. Terminating the SSL session on BigIP also allows the servers to spend their CPU cycles on serving up the content rather than doing SSL encryption and decryption work. Certificate management also becomes easier because the administrator only needs to install the SSL certificate on one device, BigIP, rather than on each pool member. Module 7 discusses SSL termination in more detail. The final profile example we'll discuss here is FTP. If virtual servers were only configured to process client traffic, what would happen if one of the pool members tried to initiate traffic outbound via the BigIP LTM? The answer is that LTM would drop the packet. There is no listener or virtual server configured to receive traffic from the pool members and direct that traffic outbound. How does the active FTP protocol work? In active FTP, the client initiates a connection, typically to port 21 for command and control. But the server initiates the data transfer connection from typically port 20. How can this possibly work on BigIP LTM? The answer is an FTP profile is used. The FTP profile gives BigIP the smarts to accept the server's initiation packet back to the client for the data transfer connection. One way to illustrate how profiles work is a scene from the movie The Matrix. The character Neo needs to learn jujitsu, but rather than training for months, they sit him down and plug in a martial arts program and voila, a master. Virtual servers learn things the same way. An HTTP profile tells the virtual server what a cookie is, what an HTTP method is, basically how to read HTTP. Other profile types and uses are discussed in the BigIP LTM Advanced Topic Instructor-led course, which can be taken at F5 training centers around the world. Some profiles require the presence of other profiles on the virtual server. The OSI model provides a helpful context for explaining this requirement. The rule of thumb to remember is, if you are using a higher level profile in terms of the OSI model, the lower level profiles are required for that virtual server. For instance, if the BigIP administrator decides to use the cookie persistence profile, then that virtual server also needs an HTTP profile. The cookie is contained in the HTTP header. BigIP cannot read the cookie without being able to read the HTTP part of the packet. Because HTTP is a TCP protocol, that virtual server also needs a TCP profile. It is important to note that two profiles cannot coexist on the same layer. For example, you cannot configure both a TCP and UDP profile on one virtual server. To use both profiles, the BigIP administrator would need to configure one virtual server for TCP and another for UDP. And one virtual server cannot be configured for both the FTP and HTTP protocols. Again, each protocol would need its own virtual server. All virtual servers have at least one protocol, or Layer 4 profile, configured. The most commonly used protocol profiles are TCP, UDP, and FastL4. You don't have to worry about which one to choose because BigIP automatically selects the appropriate one for your situation. For example, if you configure an HTTP profile for a virtual server, BigIP automatically sets the Layer 4 profile to TCP. Note that this slide shows the flyout menu for creating profiles. We will discuss the available profile types and how to configure them in more detail in the next section. Let's test your understanding of the profile concepts covered to this point. Using what you've learned, answer the questions on the next series of slides. Lesson 2, Configuring Profiles. After completing this lesson, you will be able to list the available types of profiles, examples of several types, and when you would use each, explain the steps in configuring profiles, and explain the relationship between a parent profile and a child profile. The next series of slides explore the types of profiles. The different types of profiles are services, persistence, protocol, SSL, authentication, and other. Select each tab to learn about each profile type, and click on the graphics to zoom in on configuration screens. Services profiles are Layer 7 oriented. Two examples are HTTP and FTP. Persistence profiles are usually client-oriented. Two examples are cookie and source address. Protocol profiles are Layer 4 oriented. Several examples are TCP, UDP, and FastL4. The types of SSL profiles are either client SSL or server SSL, and they are named referencing where the traffic is encrypted. Authentication profiles allow BIG-IP to authenticate clients with the assistance of authentication servers prior to load balancing traffic to pool members. One example of the remaining profile type, Other, is the Stream profile. The stream profile allows BigIP to modify content from the server before it reaches the client. Profile configuration is based on a template concept. The default profiles, or templates, are stored in the location shown and can be changed but can't be deleted. However, F5 recommends not modifying the default profiles. Custom profiles are stored in the location shown. When they are created, they are built from a parent profile which creates a child-parent relationship. We will wait until the configuration screen to discuss this child-parent relationship. There are several ways to create profiles. First, select Local Traffic, then Profiles. Use the flyout menus to get to the group and specific type, and then click Create. If you don't use the flyout menus, be careful to select the appropriate group and type of profile before clicking the Create button, or you might create the wrong type. After creating the profile from the New Profile screen, enter the profile name, and if necessary, select the appropriate type. In this example, we are creating a persistence profile, and we need to select the persistence type. The parent profile field defaults to the template for that type, but you specify another of the same type if you have already created a custom profile. As previously mentioned, this parent profile serves as a template for your custom profile. You can accept the default values for each setting, or you can customize one or more of them by selecting the Custom checkbox. Then you specify the value for each setting you are changing. It's important to understand how these custom values are treated. Settings that are customized will not change. Non-custom settings inherit the same value as the parent. If the parent profile settings are later changed, the child will dynamically receive that change also. Let's say you're creating a persistence profile and you're customizing only the timeout value. Later on, someone changes the values for timeout and mask in the parent profile. The timeout value in your child profile would not change because you customized it. But the mask value would change because the child profile inherited its value from the parent. Note that if the custom checkbox is selected, that setting is considered to be a static value, even if it matches the default value. Last, the profile needs to be associated with the virtual server before the changes will take effect. The next several slides test your knowledge of profiles. This concludes Module 5, Profiles. You should now be able to explain the reason for profiles, when to use them, and why some profiles are dependent on others, and list the steps to configure profiles, plus describe the child-parent relationship. Remember, Profiles is one of the few modules that does not have lab exercises. Instead, exercises using profiles are postponed until Modules 6 and 7 after you've learned the BigIP concepts of persistence and SSL termination. If you plan to take other modules at this time, and you've not registered for lab time, we recommend that you do so now. For the lab registration page, you can also access the PDF file that contains the lab instructions. When you have completed the lab, Be sure to answer the lab review questions. These are also contained in the PDF file. F5 Networks thanks you for attending this web-based training on BIG IP.